we see technology overheat all the time, the iPhone running super hot. I don't think any phone should glow like this. Imagine if you had that in your pocket or your bag. If you're going to overheat your lunch or your bum, it is something that's all too common in any kind of technology which uses lithium-ion batteries. Welcome to another episode of the Crossover Connections with Jack Wang Podcast. My name is Jack. We talk about the business of science and how this translates into headlines that may help us understand the jobs of the future. And to better understand this technology, this article from Vox really goes through the limitations in battery technology that we are facing globally at present. And when I talk about the limitations of any technology, I always like to pause and reflect on how amazing the existing technology already is. The revolution that is lithium-ion batteries has made our laptops, our computers, our cameras, our phones smaller and smaller and more convenient, and enabled careers of digital nomads all over the world. So really, let's just not criticize it right from the outset. Acknowledge that it is tremendous innovation and breakthrough that's even led us up to this point. The high density that is the biggest benefit of lithium-ion battery technology is also its biggest weakness, given that this high energy density makes it more vulnerable to thermal runaway and overheating, and any damage to that battery might lead to a spark that then will overheat and start a fire. Two flaws exist with this lithium-ion battery technology beyond the fact that it can be damaged and you can get fires. They seem to have a limit on how many times you can charge and recharge, or charge and discharge, and they need to be replaced over a period of time. Also, there seems to be an upper limit of the storage capacity, so especially for EVs, you don't want to have to recharge or have the fear of recharging your car constantly as you're going on a road trip. In Australia, we love to go on road trips on the weekend, and the idea of doing that with an EV just doesn't seem as safe in our minds as doing that with a petrol car. Even though we probably have to stop for petrol anyway, the idea of stopping the recharge with electricity versus refueling, it's a nominal difference that, depending on the access to circuits, might not make a difference to your setting. It does not mean innovation can just stop. We always want to make better batteries with high capacity to extend that long driving range. The EV revolution is contingent on battery technology keeping on improving. To understand where the battery can be improved, let's look at fundamentally what a lithium-ion battery is made up of. It has a number of components. So fundamentally, there is an anode and cathode that is passing an electrical current through an electrolyte solution, which allows all of these electrical reactions to exchange and take place. And this is housed within a casing that's sitting within one single battery unit. In a car, it's not one huge battery. It is a series or panels of these batteries all connected together. And there's a module of lithium-ion batteries, each of which having anode and cathode, having this electrolyte solution. That is how this entire panel and module of batteries is made up. It's not just one big battery. It is also complicated by environmental concerns in that the lithium within lithium-ion batteries, mining it is not environmentally friendly, and there's not enough lithium mines in the world to supply all the EV demand that we will need. Other metals that are commonly used in lithium-ion batteries also have their natural resource limitations. For example, cobalt. It is primarily extracted at present in the Democratic Republic of Congo, and there are all of these other complicating global geopolitical concerns with mining different things from different countries. That has led people in this sector to think about different ways they can innovate. So instead of using lithium, they could, for example, combine different materials together with lithium. For example, a lithium iron phosphate battery, and that uses a lower cost material in the battery's cathode. The downside is that, yes, it can't at present store as much energy as lithium ion batteries, but nevertheless, it seems to be a cheaper way of doing it as opposed to pure lithium. Within the cathode, you can mix it with other metals, other materials, and make it a lot cheaper. They could also consider switching out the anode. Traditionally, it's made up of graphite, but there's also a possibility of switching out for silicon. And the benefit of using silicon anodes is that they can hold up to 10 times as much charge and boost the overall battery capacity. And there's a lot of startups that are investigating using different types of anodes and cathodes in different combinations to make that battery technology either cheaper or high capacity and or safer. The other part of the battery that you could try to improve is the electrolyte, that liquid solution in which the anode and cathode are sitting, and then that is housed within a casing. If you made that liquid electrolyte solution a solid, a layer of material like glass or ceramic, then we call this a solid state battery without an electrolyte solution in it. And the advantage of going solid state, you don't have to allow for as much volume to dissipate the heat, and therefore you can make the battery packs and battery modules more compact and smaller in size. You can pack more of these solid state batteries into a given space, and you don't need to cool them using the same kind of infrastructure in place. The heat sink doesn't have to be the same shape or size, and this seems like it is the way of the future. Solid state batteries are still quite expensive to produce relative to their non-solid state electrolyte liquid counterparts, so it doesn't seem to be the solution for the time being. This is not a problem that's going to go away because we will need more and more batteries in all of our consumer electronics. Electric vehicles are getting more and more popular, and I think I'll probably get an electric vehicle as my next car. At least it'll have all functioning doors, unlike my current vehicle. So this is a problem that the people at the cutting edge of innovation need to be ready to address for it to benefit all of us. And it does have very clear environmental concerns, because this report from the CSIRO in Australia talks about the potential benefit and also the harm resulting from our inability to recycle lithium-ion batteries very effectively or efficiently. In Australia, we produce around 3,300 tons of lithium-ion battery waste every year, and we are not recycling that lithium-ion battery waste anywhere near to the level that we can be. In 2021, only 10% of Australians' lithium-ion battery waste was recycled. But if you compare that to other more traditional types of batteries, lead-acid battery, 99% of lead-acid battery waste was recycled in 2021. So we clearly know more about how to recycle that kind of older battery architecture versus the lithium-ion batteries that are becoming the default standard. And I've already talked about how lithium mining is very expensive and is very rare. So lithium is not abundant resource we can just extract heaps and heaps of. The fact that we can recycle it from existing lithium-ion batteries might resolve one of these issues. And the solution here has to be a cooperation with industry and government, and indeed researchers leading this space, because there is a lot of opportunity to develop new technologies. Not only does the trifecta of industry, government, and R&D, it also has the potential to really impact the environment in a long-term sustainable way. This CSIRO report about different opportunities industry, government, and research can work together to strengthen Australia's recycling capabilities and build new industries and new employment. I'm going to link it in the show notes below. You can have a read what innovation can lead to, both in terms of unintended consequences in a negative way, in that we need all of this extra lithium-ion battery technology, but now we have got to figure out a way to recycle it. So both of those things were spurred on by the initial need for the lithium-ion battery. To address this and to meet this gap, we need people who are very skilled in all sorts of different disciplines within science, in chemistry, in engineering, policy, in government. We need all of these people with different expertise to work together to ultimately solve this problem that we will all need to figure out an answer to, and that is, how do we find more renewable energy? How do we make the batteries in our lives that much more efficient?